Okay, as we move our way through this Unit 1 review packet, questions 11, 12 are similar to 9, 10, but they're also kind of the opposite, where now we're being given the descriptions, we have to write the equation. So, again, how I described or suggested you approach these is to write them out step by step. So, for example, we start with just f of x. Rather than keeping all these steps 1 through 4 in our head and then finding and writing one final answer, I suggest you go through and write them down each time you have a new transformation. So for example, f of x is shifted right 2 units. So I would rewrite that, f of x minus 2. And then we've kind of checked that off, question or dash 1. Step 2, stretch horizontally. So when we stretch horizontally, that means we have a fraction inside the parentheses. So here it's f of a fraction. So instead of 3, we use a reciprocal, 1/3, and then we keep the x minus 2. And we just keep going through step by step until we get the final answer, and then we box it in. Reflecting on the x, that's a negative out front, negative f of 1. And our last one shifting up 4 units. So I'm going to write that out here. Up 4. Double check that we've got them all. Shifting to the right. Stretch horizontally by 3. Reflect about the x. And up 4. We'll go ahead and box it in just because we have a lot of other work being shown. Let's move on to number 12. 12 is the same thing, but now instead of just f of x, we actually have a function of the absolute value of x. So step 1 is compress horizontally by a factor of a half. That means that we have absolute value of the reciprocal, because remember, horizontal, compress, and stretch, we use those reciprocals. That. Step 2, I can check it off. Yeah. Reflect about the y-axis. Y is going to be that inside negative. And then we can compress vertically by 1/5. So that would be that 1/5 outside. Like that. In fact, that is, put a little dot there. That is our final answer there. Make sure we've got all 3. 1, 2, 3. Okay, there we go. That was only 3 minutes. Let's keep rolling. If you have any questions on that, let me know, but they're pretty straightforward, like I said, especially if you write down each step independently. If you're given an actual function like this one's the absolute value of x, you could, if you want, you can go to Desmos and type in your final, let's do that. You can type in your final function. So we had y equals an absolute value, just start ABS and x. And it doesn't give the symbol for it, but it does use that. So this one here is y equals, I'm going to use the decimal, 0.2 times absolute value of -2x. So let's check that we have all that. Yeah, and what you're going to notice is the quote-unquote reflection across the y-axis. Well, it's already an even function, so if you take an even function and you reflect it about the y-axis, it will not change what happened. So maybe this wasn't the best example, but the point being, I had time in the video, but the point being, I wanted to make sure that you knew that you could take, when you have a function like this, and put it into Desmos. Look at the actual graphical representation and make sure that it worked. So 11 may not be the best example, but something like question 9, you could take graph of x cubed and then the graph of this function here and check to see that it did go to the left too and compress and reflect and do all that stuff. Even though you had to write it down, you can at least check your work. Anytime you can check your work for minor mistakes or oversights, you should do it. let's see. Yeah, let's keep going. That was 11, 12, 13, 14. These ones here are going to be very similar to what we've already done, so let's just go with it. First thing we have to do is rewrite it as a simplified form, so negative 2 f of, and we're going to factor out negative 3 x. Now this is going to be where we have to say plus 2. Make sure I have that right. So negative 3x, yes, and negative 3 times that's negative 6. Okay, so we checked out. In that, we look at this and say plus 2 is left 2 units. So step 1, inside most parentheses. Step 2 is any multiplications. So our multiplication inside, we have one. Again, I do it horizontal first. It doesn't matter if you do that or vertical first. Horizontal, big number means we compress. Anytime it's something bigger than 1 or less than negative 1. And horizontal, we rewrite that as the reciprocal. The other multiplication out front, 2, so that's a vertical stretch. Whole numbers out front like that, that's a vertical stretch. And we just say by the number it's given, by 2. We also have 2 negative numbers in here. So we reflect x and y. And the plural of axis is axes. So that's our step 3. Last one, I don't have room really. I'm just going to say up 1 by 1. There you go. So that's describing those in that order. Again, make sure you get that x by itself in this inside the parentheses like that first. Moving on, 14, last one here. We have to rewrite this one. This one's a good one. So 1/4, I'm just going to rewrite it that way so I can save some room. F of 1/3 x minus. Now, how do we get that to work so that we get a 1 in the end? Well, typically, the general form of this is to take the inside number divided by the number you're factoring out. And that's how you know what number to put in here. So 1 divided by 1/3, which is the same as 1 times 3, so x minus 3. And we check that again, 1/4 out front, f of 1/3 x, and 1/3 times 3, that's minus 1. All right, so got the general form, missing a parentheses. Inside most is to the right by 3. After that, multiplications, we have a horizontal stretch. The stretch, because it's a fraction, and we say it's a stretch by the reciprocal, so 3. And then we also have the vertical. And that is, that fraction becomes a compress. So they're kind of opposites, vertical and horizontal. So that's a vertical compress by 1/4. So we got our multiplications. We don't have any negations. We have no shifting up and down. We are done. So there it is. That is all of the 1.3 problems. Questions 9 through 14. And I think we've covered pretty much any type of problem we'd see on the test. So there it is.